Hello. Hello.
Yes, you are
Yeah,
audible. Go
I'm
on.
audible.
Yeah.
Okay. So good evening, everyone.
Yeah, you're audible.
Okay.
You're audible. Yeah, you can continue your presentation.
Okay. Thank you. So good evening, everyone. Myself, Namratha Upreti, and I'm a senior research fellow pursuing my PhD from Institute of Chemical Technology, Mumbai. So my topic will be advancement in biogas upgradation. The main focus will be on upgrading the quality of the biogas by using minimum energy or an energy efficient solvent. So I'll proceed with my presentation. Yeah. So basically, first the question arises, what is biogas? Biogas is nothing but a mixture of carbon and methane, which is produced by the degradation of animal waste, plant waste, etc. So when we see the composition of raw biogas, we can see it has around methane 55 to 80%, carbon for 20 to 45%, rest is nitrogen, hydrogen, and hydrogen sulfide. Hydrogen sulfide, it is a toxic gas. So the need arises why we need to do biogas upgradation. So we can say that biogas upgradation takes place in two parts. One is cleaning and one is upgradation. In cleaning, we remove the toxic gases like H2S, and N2O2 is also removed during the cleaning part. But during the upgradation part, CO2 is removed, which is a very important step because a biogas must have minimum 90% methane and 3.5% maximum CO2 N2 mixture to use as a CNG. So, and as we all know, if CO2 will be present in larger amount, it will be decreasing its calorific value, which is not a very good feature of a good fuel. So when we upgrade CO2, we can see that the methane composition changes around 95 to 99%. CO2 reduces from 1 to 5%, and there is little or no hydrogen sulfide gas present in an upgraded biogas. There are different techniques for upgrading biogas, like water scrubber, which is used around 41% in the global market, the chemical scrubber, pressure swing absorption, rest are cryogenic separation, organic scrubber, and membrane. So water scrubber, which is used in a large amount, has its own advantages and disadvantages. But here in my work, I'll be focusing more on the chemical scrubber. Briefly, I would be discussing all the methods, but my major work in this presentation would be for chemical scrubbing. So water scrubbing, the basic principle of absorption, this method is separation is based on the difference in solubility of various gases. As we know, CH4 is like methane is 26 times less soluble than CO2 in water. So by using the solubility principle, we can easily we can easily upgrade biogas and remove CO2, lower the concentration of CO2 in the biogas. We can see the advantages like although it has high efficiency, simultaneous removal of H2S is there. Capacity is adjusted by changing pressure or temperature, but the major disadvantage is that since water has a very high specific heat, it requires a lot of energy to regenerate this. Hence, as I said, my goal is to use the minimum energy for biogas upgrading. So we are not considering this method in our lab. Next is the cryogenic separation. Cryogenic separation is relatively new technique in which temperature difference is used to separate gas. We know the boiling point of carbon dioxide is around -78 degree and methane is around -160 degree. There is a lot of difference in temperature, hence this method can be applied. Although this is more advantageous when we use liquid biomethane, we have to directly achieve liquid biomethane, then we can go for this method. Again, the disadvantage is that high energy is required for cooling and it is an expensive investment. Next method is the membrane separation. which is based on selective permeability. Again, I'll focus more on the disadvantages because my work is mainly on the chemical absorption. So disadvantages like multiple steps are required.
Hello. Hello. Hi, Namratha. Yeah,
Hello.
hi. Someone is asking that your slide is not changing.
Okay.
Okay. Are you still with slide 5?
I'm on the membrane separation one. Yeah, I'm on the 5th slide. Yes, I'm on the
Is
5th
it
slide.
the, yeah, okay. So Heki, Sunayan, she is in 5th slide only. Thanks for asking.
So
Yeah,
the
so you can continue now.
Yeah, so the next technique is the membrane separation, which has its own disadvantages like low membrane selectivity, and multiple steps are required for to reach high purity of methane. Now, the basic thing, like the main work, the main focus on in my lab would in my presentation would be for the chemical absorption. So, as we know that this follows the same principle as the water scrubbing method, but instead of using water or any physical solvent, we use the chemical solvents like basically amines, so that the reaction takes place between the chemical reaction takes place between the absorbed substances. So, the main advantage is that high efficiency, cheap operation cost. The basic example, like the basic point why I'm focusing on chemical absorption is because it requires less regenerative energy, and my main aim is to provide an energy efficient solvent for this biogas upgrading. This is a very brief description which I have given in the chemical absorption method. In the next presentation, my colleague, so we are a team. My colleague will be telling the details of everything we'll be doing, the parameters we are having, the solvents we are be using in the chemical absorption. In the next few slides, I will give you a brief tour like what we are actually doing in our lab. So these are the equipments we are using. First is the absorber setup, in which we have developed a solvent, energy efficient solvent. Uh, so is it more like, are my slides moving now?
No.
Okay. Is it visible now?
Yeah, it's visible and you can on slide share option.
Yeah, I did that.
Yeah,
Okay.
there from.
So so I'll continue with my presentation. So these are the equipments we are using in our lab. So it will just the absorber setup, which is used to find the regeneration energy of the solvent. We have tested many solvents, and I'm very proud to say that we have found a very good solvent which has relatively lower regeneration energy, which is in the present in the market or the benchmark solvents. All these details will be discussed by my colleague in the next presentation. So we have used stirred cell reactor to find the solvent which has high reaction rate and everything. The vapor liquid equilibrium setup is there. Basically, there are two: the ambient vapor pressure liquid setup and the that high pressure vapor liquid equilibrium. Now, there is also setup like for batch absorption and desorption, in which we have studied the catalytic desorption also of the uh, desired solvent which we are using. So all the parameters, temperatures, pressures, all the solvents will be discussed later on. So here I would like to show one important result. Here I would like, I don't think it's moving. So here I would like to show one important result. Like we have found the regeneration energy of 38% AMP. I chose AMP, which is a sterically hindered amine, because it is the benchmark solvent for biogas upgradation in chemical absorption. So we achieved like the regeneration energy around 3.8, which is comparable to all the energies found in literature and other benchmark solvents. Keeping this, corroborating this result, keeping this as a base, we have developed an energy efficient solvent which used around 20% lower regeneration energy. So the problem addressed in this work was solvent development process, in which we were able to develop a process. Foaming problem was eliminated, regeneration energy was lower, corrosion problem was lower, and the lower absorption efficiency, which generally many amines have, that was also covered in our work. So thank you so much. Anyone wants to ask any question?